Good morning, everybody. My name is Roberto Frassina. I'm the chairman of EUCIA. EUCIA is the European Composites Industry Association, and I have the pleasure to be with Jaap van der Woude, which is the chairman of our Sustainability Committee. So today we will illustrate briefly what is our view of a very important topic, which is circular economy. So what's the role that composites may play into circular economy? It's not only an update on recycling, as you imagine, but something which is more ambitious than that. How can we use what we know about recycling to make our materials more circular? What about EUCIA? We represent the European national associations, so we don't have industry as direct members, but we are in contact with the industry through the national associations, as well as specific sector groups that are dealing with products or processes. We actively contribute to building economically and environmentally sustainable composite industry. We do our best to monitor the standards and legislation to communicate the ways in which composites may contribute to a more sustainable world, and we also promote educational activities in many sectors. We represent 10,000 companies on the European Union, and which corresponds to roughly 150,000 employees that are involved in composites manufacturing across Europe. Our motto is we know the industrial education, and we are sharing the best practices. We show we are active at the EU level and trying to influence decision makers, and we grow, so we try to foster the development of the industry and membership expansion across Europe. Our main objectives are the promotion of the use of composites due to the benefits and characteristics that they have for engineering applications, advocacy actions toward a balanced EU legislation environment for the composites industry, policy tracking of educational programs in the industry alignment, and we have the ambition of being the European platform of the wool industry and share best practices through exchange of knowledge. And we also have an active role in extending the cooperation beyond European borders into the international environment for what concerns our strategies. This is in only one slide our membership. So the blue countries are members of EUCIA, and we represent roughly 85% of the market in Europe, and that's for national associations. And our four sectorial groups are CEFIC, which is the chemical industry, and especially the UPR group, which is the unsaturated polyester resin group inside CEFIC. EPTA, which is the European Pultruders Association, is also a member, and Glass Fiber Europe and the SMC BMC Alliance. And this is our governance. So I am the chair, and we have a board of directors, and we also have working groups on several topics: standardization, construction, and obviously the sustainability committee is one of the most active inside EUCIA at the moment. So these are our main activities. So what we have been doing recently, we were able to produce and promote the so-called Eco Impact Calculator. It's a free online tool that everybody can use to make the LCA analysis of composites. It's very easy to use. I invite all of you to give to try this tool On our website, we have this very active sustainability committee. We are following standards development, especially for the revision of the Euro codes, which are the European rules for construction. We were successful in promoting a new standard for composite materials in construction that we expect to be approved by 2023, so 1.5 years from now. Once it will be in place, there will be possible to use composite material for constructions in Europe. And we also organize events and communication. We recently defined 3 main focus areas for 22-23 to demonstrate that composites are of great value, to make sure that composites are becoming truly circular, and to demonstrate that composite circularity is possible, and try to convince the European Commission to adjust the relevant legislation in order to be fair with composite materials, and that's a big challenge, as you may know. Now I give the stage to Jaap for the second part of the talk, which will deal more specifically with sustainability and circularity. Please, Jaap.
Thank you, Roberto. As you saw from the previous slide, we have a number of priorities. What I want to talk with you about is about the circularity of composites. It's a topic of importance, especially to make sure that the decisions are made on what is circularity for composites are consistent with composites properties itself. What you see here is what we always like to talk about first is composite life cycle. You make the composite, and as you have seen, we have developed a nice tool for that to establish the eco footprint for that. But there is a significant life, and life is driven by the unique properties of composites. It's often enabling, is longevity. 50 years plus is no exception, and even after 50 years, the composites are still okay, and that's why we call the last phase of a composite life end of use, not because the composite is failing, but the product is very often failing. And it's actually the topic of what we are working on at EUCIA at the moment within the Sustainability Committee. We are working on a position paper, and as a consequence a roadmap, and it centers around the fact that at the end of life composites are still composites. So how can you use them profitably? It emphasizes that in that way, if you can find solutions, that you really can say composites are circular. That brings us also to the fact that you have to change the definition of recycling from composite recycling, where you basically transform materials at the end of use life into materials components for other applications. You would like to emphasize that you still have composites, and you would like to conserve and retain as much of these composite properties as possible. So why can't you make other composites out of these composites? This is a busy plot, but the Sustainability Committee has taken initiative, like I said, to develop a position paper and a roadmap, and we want to establish a working force that expands this. And it's actually driven by the fact that circularity has becoming very essential, and we have to have an answer and a role for that. Green Deal started out as a target for 2050 on CO2, but the pandemic took care of the fact that people started to be concerned about resources. The investment community is interested, at least, in understanding what are the right investments and what is really green. Our customers are asking for why can't we increase the recycled material, and the public at large is of course also busy. On the right hand side of this plot, you see that, and there's a model that we have developed a few years ago. The top chart shows the growth of the waste production, and there are some big contributors there. Wind is one of them. You have heard about it, of course, over the last few days. And there are various segments within the composites industry that are actually directly approachable. Wind is one, marine is one, pipe, vessel. Those are well-defined entities, and they can be directly taken into processes that are suited for that. There are other segments like automotive and electronic, which have their own end-of-life regulations, which do not account completely for composites. So we have an issue there, and we have a big issue in the areas where there is actually a high degree of dispersion, which is, for instance, in the consumer area, but also currently still in infrastructure. But there are already solutions for end of life, and co-processing is one of them. Co-processing is cement, which is consistent with the Waste Frame Directory 2008, EC 1998. There's a guidance note that explicitly explains that the two components of a composite, the reinforcement materials or the inorganic material, is very well suitable for use in other processes, while the resin can be an intrinsic fuel. And there are applications, especially cement, that makes composites really very fit for that process. So today, recycling of composite in cement is commercial. It's being practiced in Bremen, and there is a customer that's really dedicated to it, Holcim, and it's an operation with significant capacity, and the capacity is slowly filled up. It's actually a very easy process. It's a grind process, and it's economically viable. People pay a fee, and the material is being processed. It's also demonstrated already a decade ago that the LCA effect is positive, because you replace materials, you replace fuel on a very efficient basis. And there is a desire to expand the use. Mainly wind blades are currently used and manufacturing waste. But there is much more opportunity for other materials like the green segments that I just mentioned. Well, this is actually a simplified sketch of a cement operation. On the left-hand side is where the raw materials are being produced, and there is a batch mixing entity. That's where also the end-of-use composites will be mixed in. It goes into the cement kiln. The flue gases are being cleaned up. This is an operation where you talk about easily about 1400, 1500 degrees C. And of course the material is ready for use. This in a simplified form shows you how a big blade can be reduced to smaller pieces. And you have to keep in mind that at the bottom line, on the left and the right hand side, you still talk about composite entities. Bigger chips, smaller chips, they are usable as composites at the end of the day. Because there is discussion at the European level, and the Joint Research Center has gotten the task to come to a definition of recycling, we felt that we have to clarify co-processing in cement a little bit better. And we worked with the cement industry, the CEM Bureau, on a position paper. Today, the cement industry is just a grown-up, mature industry where energy efficiency around 75% take place. It follows BAT, best available technology, energy recovery, and all the stuff. And they love to use other materials because they would like to lower their footprint too. So in a partnership, we worked together, and we started to really dig into the details of cement production using composites and see where the benefits are and when we can update the LCA that we already have. It's a little bit busy spot, but on the right-hand bottom side you see the phase diagram, and the blue and the gray dot are actually the compositions of the fiber and the clinker. They're very close. The compositionally they're very, very close. And on the right top side you see various composite applications with their typical amount of fiberglass, a typical amount of filler or not, and the resin. And one has to realize that especially the fiberglass is already present in the oxide form. It replaces virgin raw materials, which has to be decarbonized or dewatered or whatever. So there is already a benefit there, not only replacing one-on-one the final constituents, but also the fact that you don't have to go to the heating up to split actually the calcium carbonate and all the other materials. The resin, and that's what people have not recognized, the resin is very much mixed into the batch. So it will be heated up, it will be incinerated, it will contribute to the heating, but at the full 100%. And you remember that I mentioned that 75% efficiency is the overall efficiency. So that resin contributes more than 100%. In conclusion, the use of fiberglass as a raw material replaces virgin raw material, but all these materials together and the use of the resin in the way we are doing it gives a compounded effect that's far larger than the potential CO2 that if you look at it from the bottom. So there is a reason here to start to look again at the LCA of this material. And the right-hand side you see the previous study which already calculates the benefit at certain percentages on specific CO2. But I think with the story that I told you that there are a lot of real benefits to the cement industry and using composites, and that makes actually this recycling process really sustainable. It contributes in addition to the equivalent raw materials and energy. Brings me to, let's say, a larger scope here. This is a very busy plot. I'm not going to go this in detail, but on the left-hand side, you see actually a column that top-down talks about retaining composite properties that are partially lost. Then you have this nice blue bar with co-processing, and that we already know that has a positive LCA. And on the bottom, you see that the treatment of end-of-life composites in this case is giving actually no benefit. And we talk about milling it up and using as filler or incinerated, even with energy recovery, that's a poor process, or landfilling. That's something that over time we want to get away from. On the top you see that most beneficial, and also the simple test of how much LCA benefit it has to reuse the material is a no-brainer, and even chopping up a composite and reuse it in other forms, but still as composite, is also replacing virgin raw material, and especially the resin is a high energy content, so that would have definitely a positive contribution. The partly recoverable raw materials, sulfolysis, chemical recycling, and the last one is pyrolysis, are still somewhat under study. I think we need to better understand the LCA, but in those processes we crack either the resin or we retain the fiber, but lots of this stuff is lost. So intuitively, I think it should deserve our attention to see what are the best processes. But for the moment, bottom up to top, we think that value retention is best served by reusing composites. On the right-hand side is a recent picture on the cumulative energy density for these processes. And this is what we know. The dashed blue line is the footprint of fiberglass, about 20-25 megajoules. And you see what is actually below the line. Mechanical recycling is just processing it, and then if you use this composite, it's beautiful. And on the right-hand side, you see the good LCA contribution of co-processing, which takes us, I think, to something like a vision document, and that is this. We want to maximize value. We want to understand over time where the value is. So I think together we can conclude that what's in the red box is not contributing lots of value. The materials are being lost, the energy is being lost. In the middle, we see a pretty solid position for co-processing, and as co-processing is taking all kinds of materials but brings a positive contribution, then that makes sense. On the top we see a number of blocks that we want to investigate and develop further. The reuse of the material, reuse as a composite, and we need to understand much better what is going on with cracking the composite in components and getting particulates out of it. One can say that in the field of reusable composites, already a number of companies are commercial. One of the prize winners in this show, Continuum, has an excellent design for taking a composite apart and reuse it as composite again. So there are things going on, and even on academia there are a few people that are working on. So one of the things we need to do first is understand the sustainability of all these solutions. And we want to maximize the utility of those that have been a positive contribution. And I think there is a continuous role for co-processing, because when you look at this waste generation per market segment, then you see also that there are market segments that difficult to separate the material out. So we call this a circularity waterfall. And let me finalize with 2 slides. In general, I think short of LCA studies, there's enough potential for recycling opportunities, but many technologies need to be further developed. We need also a lot of fine-tuning on legislation. Cross-border transport is one of the painful things, but we also need to make sure that legislation is recognized what this circularity means for composites. Co-processing is there. Should be expanded. There are many more opportunities to end-of-use materials to be used in a cement kiln. But we have an issue with carbon fiber. Carbon fiber and glass fiber, and separation technologies are needed, especially when more carbon fiber is used in blades. You have to find ways to separate that, otherwise you have a new problem. And further, whatever happens with carbon fiber, we need to understand that. So, but an absolute requirement is whatever the recycling solution we choose, it has to make meaning from an LCA point of view, because otherwise it doesn't make sense. And we do this and we take this initiative because we want to control our own future. And when we don't do that, then somebody will come up and tell us what to do. And we may not like that. So we need to get the industry first in line. That is what we currently are working on. And we need to seek and support solutions that are commercially viable and also sustainability, environmentally viable. And so that requires LCA data, that requires in the end, solutions that are accepted at the legislative level in Brussels. And we need to continue to demonstrate to everybody that in that way, composites are circular materials. The fact is, we are a small organization, although we have a lot of companies that are supporting us. So, but we need to do that with other stakeholders. We need to have the legislators on board. We need to have the OEMs on board. We need to have the people that process the waste, and that we come up with joint solutions. And as we do that, I still believe that co-processing for cement, the way I described it to you, and I hope that it's clear, will have a strong foothold also in the future for composite end-of-life activities. Thank you very much. We have 30 seconds for questions. And if not, then I thank you. Oh.
There is one question there. Yeah.
Oh, Ed.
Thank you, Jaap. Just wondering about your definitions, right? You're working on the definitions, terms and definitions, I guess I'd call it, for circularity. And is that something that would be a review, available to review in other countries? Or is this something you develop and will send out when it's completed?
Thanks, Ed. That's a good question. I think that we have starting to get a concept of circularity. And one of the elements of circularity is that we strongly believe that composites at the end of life are still composites can be used. So composite into composite is a solution. But I think it has to be broader given the complexity of the market. And I pointed to markets like consumer and some of the more dispersive markets in infrastructure. We don't know yet, so we probably have to include, and that's the reason why we strongly include also co-processing as a solution, because it is a meaningful solution. So the definition of circularity is maintaining as much properties as you can with a bit kind of a bottom level. But like I said, we probably need a broader workforce to share that, but you can take this home already as food for thought. I hope that answers your question a little bit. Any more questions? Yeah, we are out of time. Then I thank you a lot. Wish you a splendid day over here and safe trip home.